This is a gate problem from electrical engineering paper, and it's on KVL and KCL. The problem is stated as follows. A segment of a circuit is shown in figure given below. VR equal to 5 volt, VC is equal to 4 sine of 2t. The voltage VL is given by option A 3 minus 8 cosine 2t, 32 sine of 2t, 16 sine 2t, and 16 cosine 2t. So looking at this diagram, our objective is to find out this voltage VL, and we know that voltage for an inductor is given by L times dIL dt, where IL is the current that flows through the inductor. So if we want to find out VL, we can go back and try to find out IL instead, and then take the derivative of IL and multiply with the value of inductor, which is 2 Henry in this case. So if we apply KCL at this node, and we assume that this is the direction of flow for the current through the resistance, the current through the capacitor goes from left to right, and the current through the inductor goes from top to bottom, then applying KCL, we can say that this 2 ampere current should equate to the current through the resistance plus the current through the capacitor plus the current through this inductor. And therefore we can mathematically formulate this equation as follows. So this is the incoming current 2, and it must be equal to this current. So this is given by negative of VR divided by 5. Especially note this sign that it's negative followed by positive. So this is minus of VR divided by 5, plus we know that current through an capacitor is given by C times dVc dt, where Vc is the voltage drop across the capacitor, and let's assume that this current is called as I sub LT. Now let's see what are the known parameters here. So what is known to us is this value of VR. So VR is equal to 5 volt, and what is also given in the question is the value of Vc, which is 4 sine of 2t. So if we substitute those values for VR being equal to 5 volt and Vc being equal to 4 sine of 2t in this equation, we can come up with the expression for ILT, which is equal to 3 minus of 8 cosine of 2t. And then the next step is pretty easy. We know that the voltage drop across an inductor is given by L ddt of the current through the inductor, and the inductor current we have already derived to be 3 minus of 8 cosine 2t. So this results in the final value of VL being equal to 32 sine of 2t. So for this question, option B is the correct answer.